Okay, so yeah, really nice to see you guys today again. And today I'm going to introduce the new features that we released on the 202 and 201 Trion model, and also for the iPad version Trion model. Okay, and the main topic is mainly about the PPK solution. Yeah, this is the biggest change we made on the 202, and in the section analysis modeler. This is another paid feature on the 201, and also iPad 1.4. This is for free now, but just in a limit time. So in the future, we have planned to change it to a paid feature, so you can ask your end users to download and try this function since this is free now. Okay. And after all the introduction finish, we will go to the Q&A part, and everybody can ask your question in the Q&A part. And before this part, yeah, please mute yourself. Yeah. Okay. And for the 202 of Trion model, we just released it yesterday, and if you want to update it, here is the link. You can download from this link. And also you can go to the FJ Dynamics website to download the installation package. And also you can check the updates on the Trion model multiple ways. Yeah. Share my screen. Everybody can see my screen now, right? Okay. Share my screen. Okay. Okay, so let's go to the first function. So the first function is the PPK solution. You can see there are two functions when you open Trion model. The first one is the PPK calculation, and the second one is the base station data. Need to combine them to use as one function. And hold on, let me open the data. And before I start to introduce the PPK function, I would like to introduce a bit of how the RTK works. I believe most of you guys know how RTK works, but just to introduce a bit to bring the RTK fusion, the PPK fusion. And as you know that if you want to connect to RTK, there are two ways. Okay, the first way is you set a physical base station by yourself, and then the base station collect the differential data and share to a rover, and then through this way to correct the position like offset during the moving. And another way is you don't have any base station, and in your city, in your country, there is a entry provider. They sell a lot of base station in your city, and they keep observation, and then they storage the differential data in their server, so you can get the differential data from their server by subscribe to maybe their service, and then through this way you can also get the differential data to correct the positioning offset of yourself and your rover. And since there are two different ways to get RTK, we have two different ways to get the raw data, which is the raw observation volume data from the base station. And before you start set the base station, there are some preparations. In the last training, I introduced the new feature that we added on P1. We add a new format on the transcan. After you finish the scan with the rover, you will be able to download a data named with the RTCM. That is the raw observation data from the Attica rover. Okay, and for S1, it will be 2.5.1. It is not supported yet, but coming soon. Yeah, so you only when you update the software into the newest version, this function can work. And for Transcan, the mobile app, then you need to upgrade to 1.6, and for Trans Survey, it is 2.0.9.1. Yeah. Before you start to set base station, you need to make sure that all the software is the newest, and then you can go to set the base station. Okay, the first type is you don't have cold station, and then you use the physical base station. Step one, you need to find an open area to set base station, and then record the coordinate of the base station, and then you also need to record the height of the pole and the height from the base center of the RDK to the pole. Okay, and after the base station is set, you go to the settings on the Trion survey, and there are some parameters you can see, at least that here. You just open the Trion survey and then set sorry, it blocks here, and then go to set it as a base station. Okay, connect to Trion survey and set it as a base station. Yeah, set it to base station mode, and then open static record. Yeah, it can work just after it go to the single solution, and then you start to record the static data, and then there are some settings. Just at least that on here at least that here. Just follow the parameters to the setting will be okay. And then after all the parameters setting, just click start to record the raw observation data from the base station. And here you also need to set the antenna height. Here you set the metal height is the height of the pole, and the total height is include the base center of the rover. And for Trion V10, the value is 0.081 centimeter, and for V1T is 0.069 centimeter. And save the file as a .rdcm file and just start record. Yeah, and then you can connect your rover to the base station to start the scan with the scanner. Okay, this is the first way to get the raw data from the base station. And the second way, if you don't have a physical base station and you use the Entrip service, and you also want to do the PPK calculation, here you have maybe you can use Google Map. In China, we use Baidu Map to locate ourselves. You just open the app and then find your location and zoom in. As accurate as possible. Maybe the area should be within, it is recommended within maybe 10 meters. Yeah, as long as you can find the building you are in, and then click on it, and then find your coordinate. Find coordinate here and copy the coordinate. Okay, and then go to Trion Model. Go to Trion Model. Sorry. And enable the base station data function. And here has another video. You go to the base station function, and then type in your okay, go to base station function and type in your course account and IP address port, and if there's like option that is your Ntrip server service provider, you can just choose it. If not, you can just choose other. It's okay, and then type in your location. Type in location, and this function will help you to get the raw data from the server, and it will output a .rdcm file, so you can get the raw data from the base station now. Yeah, for Ntrip, you need to use this function to get the raw data from the base station, and for a physical base station, and for physical base station, you have already recorded, right? The raw data has been recorded, and what you need to do is take the base station to your office and connect it to your computer via a Type-C cable, and then go to find a folder named static, and then just go to copy the .rdcm file, and you will get the raw data of the base station. And there is one thing was to mention that not only V1 and V10 I can support this, as long as the base station can export the RTCM file, it will be support. So you can use a third-party base station, maybe Trimble, some other kind of brand. Yeah, up to you. As long as you can make all the parameters corrected, and then it will be works. And okay, the step one, the raw data from the base station is finished, and then we go to the office. You go back to your office, and then you go to process the raw data of the base station. Sorry, there's after you finish the execution of the base station data, you can connect the scanner with RTK to do the scan, right? And then after you finish the scan with the RTK rover, you can download the data. You can download a RTCM file from the transcan. This is the raw data from the RTK rover. So now, after you get the raw data from the base station and the raw data from the RTK rover, you can go to Trion Model to process the RTCM file now. You just go to the PPK calculation function. And if you are using a physical base station, you can just enable this option, and then import the coordinate that you recall in the beginning when you set the base station. Coordinate is is the point of this. Sorry, is the coordinate of this point. So you just import it here. Nose is in height, and here you also need to type in the height of the base station, and then here choose the .rdcm file from the base station, and here you choose the .rdcm file from the article rover, which is the file you downloaded from the transcan, and then choose a folder to save the RTK file after the PPK calculation, which is a .fjD RTK. So it will be like this. PK solution. You go to the PPK solution, and if you are using CORS, you just disable this function. But if you are using physical base station, you just enable this function. So we recall the coordinate of the base station and we type it. And after the calculation, it will give you a new file, new .fjrdk. So yeah, there will be a new .fjrdk. And then you can use this new .fjrdk to do the RDK fusion. And so the reason why we use the PPK solution to regenerate the FJD is sometimes when you do the scan with the article rover, there might be some interference. It was like the point cloud data. The real-time data always have some interference, and accuracy may be not the best. And if you find that you don't have a good accuracy during the real-time scan and real-time process, you can try the PPK solution. Yeah, sometimes it can help you to correct some RTK error. And after that, you go to the RTK registration. In this function, in this version, we also made a big change on the RTK fusion. Okay. So we also made a big change on the RTK fusion. Let me import data. plan. Okay, now when you go to do the PPK calculation, you see, sorry, when you go to do the article registration, you see that there is a setting here. You can go to set the projection 7 meters and 4 meters and elevation fitting. You can set it here. So it helps you to better to find your coordinate system or define your coordinate system. And also when you start the article fusion and point cloud mapping, you can have this option as well. And in this version, when you if you want to start an article fusion, design the FJD article file, you also need to choose a coordinate system. In the previous version, you don't need to choose a coordinate system, but in this version, you need to choose one. And this is a small difference. And here in the advanced settings, we also made some change. When you do the point cloud colorization, you can define the coloring frequency, the higher the best. And object removal is about the color. Like sometimes there is maybe the top of the building of or the trees maybe get some color interference from the sky, so you can enable this function. And motion blur is sometimes if you move to first some frames of the point cloud, of the image may be blurred. So you can use this function to create it as well. So this is the change. And then we go to the section analysis. And yeah, as I say that this is another paid feature. And this function is used for the result acceptance in the tunneling industrial. And this is not that easy for everybody to know how to use this function in details because it has a certain it has a relative high professionalism of the tunnel survey and tunnel industrial. You have to know how to dig a tunnel and the workflow of the tunnel excavation. So I won't explain all the parameters in details. I just introduce a basic workflow of how this function works today. To understand how to use this function, I need to introduce a bit of introduce a bit of the channel excavation. Step one, if you want to start a channel excavation, you need to design a axis line. This is also the trajectory of the tunnel. Like this, you design a axis line, and then the second step, you need to design the section. Like, is it a circle? Is it a straight line and a curved line and a straight line in a straight line, or is it a straight line, straight line, straight line, a polygon? Yeah, different kind of shape. So you need to design them yourself. And after the section and the AC slide is designed, you can start the excavation of the tunnel, right? And the section has to be vertical to the AC line. So you start to dig the tunnel, and it will go like this. And after you finish the excavation of the tunnel, you take the scanner to scan the tunnel, and then you import the data in Trion model. Okay, you finish the scan and you go to and you export. You do the post process, and then you get the point cloud data, and also you have the axis line parameters and the section parameters like this. This is provided by the excavator team. So you have the lines parameters like this. Sorry, this is the control point. Yeah, curve line, straight line with all the parameters, and the section parameters. And then you go to import it here. The first parameters is the axis line, and the break line is like if there's only one team to dig the tunnel from the beginning to the end, you don't need to enter these parameters. But sometimes the tunnel is too long. You need multiple teams to dig at the same time. So this function, these parameters, is to combine different teams, like mile age. Yeah, to combine different teams mile age, like the first one 100 to 410, the second, and then 8, another team's excavation, and then combine them to one file. And then next parameters is to design the shape of the axis line. You can see we have two methods here. The first one is intersection. The second one is light element. And maybe in the future, we will add the third method called the coordinate method. So yeah, so basically, the first one intersection method is to define the light via the intersection points coordinate. You can image this. You can image this. If you want to design a light, first you draw a straight line, you define a straight line, and then you want to define a curved line like this, right? And then you want to define a curved line like this. And then what you need to get is the coordinate of the intersection point, is this point coordinate. Through this point, you can define this line. So this is the intersection method. And the line element method is different from the intersection method. This is to define through the intersection points coordinate, and this you just enter the parameter of the line. If you want to enter a circle curve, and what you need to know is only is only the radian, and you type in the beginning my age and ending my age, and the starting and ending coordinate, starting XY coordinate, and just type in the radian, you will get a circle. So this function is to enter the parameter of the lines directly, and after that, after you finish the design of the axis line, and you will go to the section design. Also, this parameter is provided by the excavator team. And then you can see different lines, straight line, arc line. Yeah, usually section usually a section is combined by four or five lines. Yes. So you just type in the parameters of the lines, and then you will get the vector. After you finish the design of the axis line, you get a axis line vector. Then after you finish the section design, you get a section design vector. And in this version, the vector is not visible. But in the future version, we'll make it visible, but this version not supported yet. So you cannot see it, but it is generated. And after the design of the axis line and the section, you will be able to generate sections. You click on the point cloud and you click on this function. And then you choose the axis line. Sorry. Can you mute yourself? We will have the Q&A part in the final 15 minutes. Okay, and after that you can choose axis line to generate the section. Yeah, the section will be vertical to the axis line. And here you can define the starting mile age and ending mile age to generate the sections. And the mile age interval, like the distance of different section, you can define it. And the thickness of the section, yeah, you can also define it. And then click on OK. You will generate multiple sections like this. Yeah, and after that you will generate multiple sections. And after the sections generated, okay, after the section generated, you can start to do the section configuration. So you can choose all the sections, or if you want to compare one section, you just click on one section. Yeah. And then here, this function will be activated. You click on it. And then there are some parameters. The number of the sector points, yeah, you can set it yourself. And the selection algorithm and the closest normal point. You click OK. It will finish the analysis immediately. This function don't take too much time. Okay, and then you get the comparison of the section. And you can see there are two shapes. The green one is what it should be. Like it is generated based on the parameter you set it. So this is a straight line, arc line, and a straight line and a straight line. So this is generated by the parameter you set it, and this is the real condition finished by the excavator team. So you can see somewhere is they overtake, they did too much, and somewhere they didn't dig enough. So you can generate a report. You click on this section, and here is a result annotation. You click on it, will generate the difference that between the excavator team and your design parameters. Also, you can do multiple annotation at the same time. Annotation at the same time. And click on this function. There are some options as well. Here, menu is that you mark the point and get the offset itself, and automatic is to generate the report in a certain interval, like 0. I set it 0.5 units meter here, and you can click apply to all sections and click preview. It will be like this. You click OK, and then you will see all the difference in all sections. You can see the red is the red node is over thick, and the blue is that not enough. And here you can see the age pi number, and yeah, some parameters, the theoretical area and merit area. And through this report, you can decide to send the excavator team back to the tunnel to redig it or not. Here you can generate a report and type in the project name, merit person, review person. Yeah, there's some options. Just save it in desktop, anywhere, any folder you want to save. And then you get the, okay, sorry, I choose the wrong folder. Choose, save it to desktop, click OK. And then, sorry, and then you will get a report. Project name, measurement time, measurement person, like this. And this is for one section. And if you want to generate a report of all sections, you just choose all the section and start to export it. So yeah, this is the whole workflow of this function. And the parameters is all provided by the excavator team. Okay, this function is done. And then we go to the iPad version Forestry module. Yeah, we have this function in Windows version, but it is a paid feature. Maybe not everybody has this model, but not in the iPad version. It is for free, so you can try. And the whole logic of the data processing is close to the Windows version. Let me share my screen. Oh, my iPad. Wait a minute. Hold on. Need to set the screen. Okay. Okay. So about the forest model on the iPad Trion Model is open the point cloud data. Yeah. And then you can see there is a forest modeler here. You can see there's a forest modeler here. You click on it and you choose the data. Yeah. Choose the data. And then you can see the first function is split. This is like the function we have on the function uh, ground extraction we have on Windows Trion Model. And here you can choose the ground type. This is a small difference, but almost close. And the second option is the forest type. You have roadside forest and artificial forest, different kind of forest. Just choose it according to your real scenario and just confirm. And then it will start to collect to find the ground and the trees. Takes a big time to load the data because this data is big. Yeah, big. And after the sorry, after split, this is sorry, I just make a mistake. This is like the segment by tree function and in the Trion model, Windows Trion model. And then you get the single trees, right? And here you on the bottom of the trees, you can see the number of trees. And then click edit. You can, yeah, you have the resegment and merge the late to merge or separate the tree. Also, like the function that we had it on the Windows Trion model. And then you can go to the analysis function. It will start to calculate coordinate tree height dp edge. The first three parameters can be cancelled every time you start a calculation. If you included these three parameters, and the others you can decide to do the calculation or not. And this is to calculate the stock volume. Yeah, the translation has maybe has small area. This is to calculate the biomass, and the carbon storage age also allows to be calculated. And here you have currently the region, we only have China and Japan. But if you have like special trees, you can define the formula by yourself. Yeah, can define the formula of the trees calculation if you know it. And then you just click on confirm. It will start to calculate the parameters of the trees. Here you can see the progress. And then you can measure some parameters of trees. Click on measure and you click on the tree ID. You will be able to measure the tree height. Yeah. The db edge and the crown weight. Yeah. These are the parameters that can be cancelled during the calculation. Every time you do the calculation, you will have these 3 parameters. And also you can export a report. You type in the survey location and the date, the unite, and the surveyor. Yeah, you type in the surveyor. And then you can generate a report. And yeah, the report, yeah, this is the preview of the report. You can see a little bit difference between the Windows version, but yeah, almost close. You can see compared to the Windows version, the iPad version has some charts, right? You can see the tree height is gram and diameter and dbh is gram, and the distribution map. So there's some small difference. And yeah, and the parameters you choose on the on the calculation, x, y, z, the coordinate, and the dbh, the height, ground waves, this kind of parameters. And then you can save it as a report. You can save it to a local folder of your iPad. So this is the Forest modular on the iPad version. Yep. So I guess we still have, okay. So the introduction of the Forest modular on iPad version is done. And we still have 8 minutes to introduce the other functions.